Hi friends, in this video we're going to talk about how to run a PostgreSQL database as a Docker container. By the way, the whole content of this video is present in this blog post. I will leave the link of this blog post in the description of this video, so please check it out. I've already made videos on how to install PostgreSQL database directly in Windows, and I also made a video on how to connect Grafana with PostgreSQL. I will leave the link of these videos also in the description. You can check them out if you like. Now, why do you want to run PostgreSQL as a Docker container? Well, there are some advantages to it. The first thing is it is really easy to set up, and the next thing is it is really easy to destroy the container once your work is done, and that is why it is really ideal for the testing and development scenarios. And one more very useful advantage is that you can run multiple Postgres instances in a single machine very easily using Docker. And so Docker is really ideal to create easy temporary isolated environments. Let's try to install and use Docker. We are going to use Docker Desktop. Docker Desktop gives you the Docker engine and also a desktop UI where you can easily see the status and even delete or create containers and do a lot of useful things very easily. So let's search for Docker Desktop. Click on this, and here we are in the Docker site. Let's try to scroll down and you can select download Docker Desktop, and I'll download for the Windows. Now Docker Desktop is downloading. I've installed Docker Desktop. So after installing Docker Desktop, just search for Docker Desktop in your computer. You can see the Docker Desktop icon. So this is how the Docker Desktop looks like. And here you can see the containers, images, volumes, all the menu of the Docker Desktop. Currently we are running no containers. If we had containers, in this containers tab, the containers would show up here. Let's try to see the steps how to install the PostgreSQL Docker image and create a container from the Postgres Docker image. The first step is to install Docker. We have used Docker Desktop and installed Docker. And the next step is to search for your image in the Docker Hub. So the Docker Hub is present at hub.docker.com. So let's go to hub.docker.com and search for Postgres image. So I am at the Docker Hub, hub.docker.com, and I will search for Postgres. So we got the first result, Postgres. So this is the official Postgres Docker container. Click on this. And here you can see the command to install this Postgres Docker container is docker pull Postgres. So the image name is Postgres. So if you run this docker pull Postgres command, the Docker image of the Postgres SQL database will be downloaded from Docker Hub into your machine. And you can have multiple versions of the Docker container. They are called tags in this Docker world. So there are a lot of tags. That means a lot of versions you can download. You can download PostgreSQL 13, 14, 15, 17, and whatever the versions which are available. If you directly write docker pull Postgres, the latest version would be downloaded and the image will be kept in your computer. And using that image, you can create containers. Well, ideally, you can open a command prompt in your computer, but there is a convenient terminal button here. Let's try to open this. So this will open a terminal inside the Docker desktop itself. You can even run the command in your command prompt, but this looks easy. So I'm going to write docker pull Postgres, and since I've already pulled the image in my machine, it is showing that image is up to date for Postgres latest. Otherwise, Docker would download the image from the Docker Hub. So now you got the Postgres Docker image. You can verify that using this image menu, and let's try to close this terminal, and here you can see the Postgres image is downloaded. Now we are ready to create containers using the Postgres image. So we have searched for our required Postgres image, we have pulled the image, and if you wanted specific version, you can write docker pull Postgres 15, 14, something like that. Now that we have pulled the required Docker image, let's try to create a container. Now to create a container from an image is very easy. I can just write docker run Postgres. Now Postgres is the image. If you had some Redis image, you can write docker run Redis. If you have some MySQL image, you can write docker run MySQL, so on. Let's try to run this. Now you can see in the containers tab, a new container has been created. Of course, we had some errors. Database is uninitialized, super user password is not specified, and all that. We will address this in a while. In fact, it is giving me some clues to set an environment variable like Postgres password equal to password and so on. But the bottom line is if you write docker run image name, a container will be created and the Docker container would be run. And one more thing to notice here is a random name would be generated to a container. In fact, let's try to run this command again. Another random name container has been created. So you have to go ahead and manually delete these Docker containers. So let's try to add some command line options to address these issues. So we set docker run Postgres. The first error was there was no super user password set. Well, in the PostgreSQL Docker container, if you set an environment variable, While initialization, it will create a super user with the specified password automatically. So let's try to give the environment variable here. So I'm going to say environment variable minus e Postgres password equal to db password. So this is going to be my database password. And one more thing is, every time you run the command, a new name is being assigned to the Docker container. So if you want a constant name, specify it here. So I can say docker run minus minus name mydb1. So every time you run this command, the container name would be mydb1. That means you can manage only one container. And one more thing we noticed is that we need to manually delete the container. Instead, I can just say minus minus rm, which means it will delete the container once it is stopped. And we can also specify an additional flag minus d, which will run the container in detached mode. That means you can even close the command prompt, the container will run in the background. So this one is also a very useful flag, minus d, which is detached mode. And one more requirement would be the container should be exposed to other applications. By default, the container ports will not be exposed to other applications. You need to explicitly expose the container ports. So for that, I'm going to write minus p, that means port mapping 5432 to 5432. That means this is the host port 5432. The 5432 host port would be mapped to the 5432 Docker container port. Suppose I'm running multiple Postgres instances, I can say something like 5433 host port would be mapped to 5432 host port of the container. So this way I can run multiple Docker containers at multiple host ports. Now with this setting, Docker container is available to other applications to be connected. And now let's do the folder mapping of the database's data folder to our host machines folder. Now why should we do that? Once the container stops, it will be destroyed because I've said minus minus rm, right? That means you start your container, you do some database changes, the data would be stored in the container, and once the container is stopped, the data would be destroyed. This is not desired, right? You want the data to be persisted in your machine. So that's why we do this setting minus v, and we are mapping the C DB folders DB1 folder to the var lib PostgreSQL data folder. So this is the folder path inside the container where the database data would be present. And now I am mapping my C DB folders DB1 folder of my host machine with the PostgreSQL container folder. So if the container is destroyed, the folder's data would be present in this folder still. That means if I run this command again, the new database container will not start from scratch. Instead, it will use this data folder. It's like restarting the database engine. So this setting is important if you want to persist your database's data in your machine. And that's it. We have covered the common requirements to run the PostgreSQL database Docker container. Let's try to revisit the settings again. Minus rm means the Docker container would be deleted after it is stopped. We have given the name explicitly so that a random name will not be assigned to our database. I have given minus minus name mydb1, so the container name would be mydb1, and I have given an environment variable Postgres password equal to this password. So when the database is initialized, a new super user will be automatically created with this super user password. And minus d means the container will run even if you close the command prompt. And minus p 5432 is basically the port mapping, and minus v is used to map the host folder with the containers folder. That means the data of the container would be persisted to the host folder. And obviously at the end I have written Postgres because the image which I have to run is Postgres. You can even give a version something like Postgres 14, which will bring the container with this tag. That means the PostgreSQL version 14 can be run. Alright, now our command is ready. Let's try to run it in a command prompt. So I'm going to copy the command. I open a command prompt. Let's try to paste the command and run this. You can see a container is created with some ID like this. Let's go to the Docker desktop, and now you can see a PostgreSQL container with the name mydb1 is running in the Docker. Now since I've used minus d, which is detached mode, I can even close the command prompt and the Docker is still running. And now you might want to connect to the Docker container something like SSHing into a Linux machine. So docker exec is used to run a command in the Docker container. So I want to connect to the database using PSQL. So I'm going to write docker exec mydb1, and the command I want to run is PSQL. But since I want to interact with the container using the command line, I need to write minus IT flag. So minus IT flag creates an interactive pseudo terminal with the PostgreSQL container. And obviously while using the PSQL, you have to use the Postgres user, not the root user, right? So I'm going to specify the user explicitly. So I'm going to say minus u Postgres. This means this command will be executed in this container with this user. So this is our command. Let's try to copy this and run this. So docker exec -it -u postgres mydb1 psql. Now I've got an interactive command prompt to interact with my PostgreSQL database inside the container. So I can see the list of databases something like \l. You can see it's working. I can see the list of schemas using \dn. I can see the list of tables using \dt. I can see the list of table spaces using \db. And you can do a lot of PSQL stuff using this command line. And after the work is over, we can just write exit. Now we have exited the Docker container. So this is really useful when you want to connect your Docker container and debug your database. So these are the simple PSQL commands you can use. And one more use case could be you want to see the PostgreSQL container logs. Now I got my PostgreSQL running. I want to see the logs of this PostgreSQL container. How can I do that? You can just say docker logs -f mydb1. -f means follow. That means while the command prompt is open, new logs will also be appended. So let's open a command prompt. The command is docker logs, the container name which is mydb1, and you can write -f to update the logs in real time. So just click enter. Now you can see the logs of the Docker container in your command prompt, and if new things happen, new logs will also be shown in this container in real time because I've used the -f flag. So this is how I can see the PostgreSQL container logs. By default, the PostgreSQL container logs are being logged into the standard output, and that's why I've used this command docker logs -f mydb1. But when the container is destroyed, the logs will also be destroyed because the logs are being sent to the standard output, which is a command line of the Docker container. What if I want to store the Postgres logs? Now that can be done very easily while creating the container. At the end, you can give a container command, and I'm giving a container command -c logging collector equal to on. So while the container is running, this command line argument is being given, and this command line argument actually stores the logs into a file present in this folder of the container where lib PostgreSQL data log instead of sending the container logs to the command line output. Using the v flag, we have already persisted the val lib PostgreSQL data folder. So obviously the PostgreSQL data log folder will also be persisted in our machine, and we can retain the logs even if the database is destroyed. So all I need to do is add this extra command line argument -c logging collector equal to on to our existing PostgreSQL command. So this was our command. Let's try to add -c logging collector equal to on. Now let's try to destroy this container, delete. In fact, let's try to verify whether our container data is persisted in our host machine even after the container is destroyed. So the folder in our machine was c db folders db1. Let's try to copy this path. And now I'm in the c db folders db1 folder, and here the PostgreSQL database container data is persisted. Now if I just copy this command and run this in my command prompt, the container is created, but the data is not from the beginning. The data will be picked up from our previous container. So again, my db1 container is created, and if I go to the database folder, go to the log folder, you can see there are logs created here, and in the latest log I'm able to see the log data. So this is how, just by adding a simple command line argument to the Postgres run command, I can persist my PostgreSQL container logs into a file. Now let's see another important use case, which is database initialization SQL. Say I have an SQL which creates some initial database tables like employees, office addresses, etc. So suppose I have all my database initialization script in this dbinit.sql, and I want to run this SQL when the database is run for the first time. So that can be done very easily by mapping this file to a database's special file, and the special file is located at this location inside the container docker entry point initdb.d create tables.sql. So just like we mapped the data folder, we can just map this SQL to the database's SQL file using -v command line argument. So in our command to run the Docker container, let's try to add another folder mapping here. So I'm going to say -v the path of the init SQL. In your case, you can give the absolute path also. And I'm mapping this init SQL file with the Docker containers SQL file, where it is present at the location docker entry point initdb.d folder create tables.sql. And that's it. Now when you run this container and the database is running for the first time, this init SQL content would be run by the database. So this is very useful if you want to create some seed tables and seed data and something like that. So that's it. We have completed most of the required options to run a PostgreSQL Docker container. Instead of running this Docker container as a command, you can create a YAML file and specify the same container specifications in this YAML file. So this is called a Docker Compose file, where you can create a bunch of containers from a single file. The use case might be like you want to create a database container and an application container and some other cache container. You want to declare everything in a single Docker Compose file. And you can even specify things like shared volumes, dependency of one container or another, something like that. So here in a folder, I have created a file called db.yml. Let's try to edit this. So this is a YML file and all the containers should be present in the services section. And here I'm creating a container called db, and obviously I'm taking the image from the Postgres, and I'm saying restart always. That means whenever the container is stopped, restart it. And this is the health check command which we run every 5 seconds to see whether the Postgres container is running or not. And we have given some environment variables, the Postgres password and the Postgres user. So this is the super user and password, and we are given the port mappings 5432 5432. That means the host port 5432 would be mapped to the container port 5432. And we have created a volume called dbvol in the volume section, and it is mapped to the folder c db folders db1, and we are using this dbvol in the volume section of the container. So I'm telling that this c db folders db1 would be mapped to the var lib PostgreSQL data. And we are giving additional command line arguments -c logging collector equal to on to persist the logs to the folder. We can even supply the initialization SQL just by using this host file address init SQL to the Docker container address docker entry point init create tables.sql. So the whole command line has been translated into a Docker Compose file. You can save this YML file and run Docker Compose to create the Docker container. Let's try to do that now. In fact, let's try to destroy our container here. Now I have opened the command line in the folder where the .yml file is present. So I'm going to use Docker Compose to create the containers from the YML file. The command is really simple. I can write Docker Compose, the name of the file -f db.yml. You can give absolute path also, but since we are in the same folder running the command line, I'm saying -f db.yml and say up. Now the containers mentioned in the Docker Compose file would be created. You can see a network is created, a volume is created, a container is created, and the container can be seen here also. Since it's a service, it's a group of containers, and if you expand this, you can see the container db1. Now if I just stop this command line, you can see the containers are stopped. So to address this issue, you can run the docker compose command in detached mode by adding -d at the end. And if you click enter, even if you close the command prompt, the Docker containers are running here. So now in the future, you can create multiple Docker containers in the file. Like suppose I have Postgres here, you can have some Redis container also. So the whole group of containers can be declared in this YML file. So that's how you can run the PostgreSQL from the Docker Compose YML file. And that's it. We have covered most of the use cases to run a PostgreSQL Docker container. You can see I have created a blog post on running PostgreSQL as a Docker container. I have given you the notes, the images, and the commands so that you can run your own PostgreSQL Docker containers. I have also given references to the official documentation, so please check out the link of this blog post in the description of this video. Please ask questions or post your valuable feedback in the comment section. Hope you like this video, guys. Thank you for watching. Peace.